find the line of best fit doing a linear regression. The first thing we want to do is we do want to turn diagnostics on. So I'm going to hit second catalog down here, second 0, and then I'm going to scroll down until I see diagnostics. I'm not sure why the calculator doesn't have those on to begin with. But once you turn them on once, then you're good to go. So I'm going to hit enter, and then I'm going to run that command. And now my diagnostics are on. And let's go and clear that. I want to run some stats, right? So I'm going to hit the stat button. I can't do any calculations yet, but I do need to edit. So I'm going to hit enter. I'm going to edit. And I have some data in L1. Now you can just go over to L1 and you can replace that data by just putting in the data you want. Or you could just go up to L1, hit clear, and then hit enter, and it did clear it. So I don't think I have any data in any of my lists now. L1 is going to be my X values. So if I'm looking at this housing one, I got to make sure I'm using the correct one. I'm going to use the square footage for my X value. Again, a lot of people switch these sometimes just based on the fact that when you're looking at the table given in class, it tells you the Y values and then the X values. But remember, we want to use the X values into Y1. So I'm going to put in the 1400, the 1600, 1700, 1875. These are all 1875. These are all square footages of different houses. And then we're going to put in their corresponding values. 50, 2350, 2450. So I'm putting in all this data, 1425 and 1700. If you already have all this in, you can skip this part of the video. Okay, so now I'm going to go up and make sure I enter the corresponding Y values to each one of those. So 245,000. Again, the Y values are going to be in thousands. 312, 279, 308, and 199. Oh, buddy. 199. 219. 405. 324. And 319. And our last one, 255. Okay, so we have all these different houses. Square footage, price, square footage, price. And hopefully there's probably a fairly decent relationship between the square footage of your house and then the price of your house. Based on that, is even something on a real estate like handout. They for sure, that'd be something they would say. Okay, so we have this data. Now let's go ahead and see if we can just see this. We hit graph and I don't see anything. Okay, so there could be two problems. Number one, your stat plot might not be on. So instead of going into Y equals, see above there we see stat plot. So if you hit second, Y equals, oh, look at that, they're all off. So I'm on plot 1, and plot 1 is going to do L1 and L2s. So I'm going to hit enter, and then it's going to give me this stuff. You don't have to change any of this, and then you just hit on. Okay, so now my stat plot is on. I can hit graph, and I still don't see anything. You're like, well, what happened? My stat plot's on, my data's entered. Well, if you think about it, we were graphing X values. Look at your list again, hit stat, edit my list. Look, my X values are the size of my house. Those are going all the way basically up to like 3,000, 4,000 square foot house. And then my prices are going all the way up to like 400 and 5,000. So I got to make sure my window is correct. So I'm going to let these houses go all the way up to, let's say, a 4,000 square foot house. And then I'm going to I'm going to let them cost all the way up to, let's say, 500,000. So now I'm looking at a bigger range of square footage and a bigger range of prices. And now when I graph, I should see my stat plot. Oh, did I say 400? Did I say 4,000? Let's look at that again. Stat, edit. Oh, we need to go up to 3,000. That was silly. So we need there. Okay, so now we're letting our houses go all the way up to like a 4,000 square foot house and cost up to 500,000. And now when we graph it, we're going to see the houses. Okay, we don't have the line of best fit yet, but now we see this. Again, you're going to have to adjust your window based on the data. If you don't see the data, your window is not correct, and you need to think through your lists. Or you just don't have your stat plot on, which again, to turn the stat plot on, just go second here and then hit this and then hit on. Okay, so we're on our graph. Now I want to actually find the line of best fit. So I want to do more calculations. So I want to hit stat. I don't want to edit the list anymore. I don't want to sort it. I want to do a calculation. So I want to go over to calc. And then for us, I want to run a linear regression, which means I want to find the line of best fit. That's number 4. So I can hit 4. And this will already be by default. It thinks the x values are in L1 and the y values are in L2, which they are. We don't have to worry about that third thing. If you want to store the regression equation, meaning it's going to find you the equation, if you want it to put it somewhere, that's fine. You can hit vars. You can scroll over to yvars, and we're with functions, and then you can hit y1. So now it's going to do a linear regression on L1 comma L2. It's going to store the equation into y1, and then all you got to do now is say, hey, calculate it for me. Okay, so y equals ax plus b. I'm not sure why they didn't use m there, but they didn't. So this is your slope, the slope of like 0.11, and then a y-intercept of like 98, and then an r-squared value of 0.58. So it's moderately related. Certainly there's going to be some small houses that cost a lot based on just where they live, or maybe they have a pool or a sweet patio, and then there are some really big houses that don't have any upgrades and maybe don't have a yard. So it's not always a big house is expensive and a small house is inexpensive, but in general there is a moderate relationship between the square footage of your house and the price of your house. So now when I hit y equals, you can see that it stored it in there. Now it stored that whole thing. Let's say it didn't. Let's say when you hit stat and you couldn't figure out, it's fine. You still know that the slope was like 0.109, like 8. You could have just wrote that down, and then you could have just added the 98.2, and you could just type it in yourself. It won't matter. So I have my data. I have my line of best fit. I can see that it's a positive relationship. It's moderately strong based on the r-squared value of 0.58, so there's a good chance. Now I can go through and answer some of these questions. They ask you about the slope. Now remember, you're graphing square footage versus price. So the slope is the increase in dollars per square foot, like it always is. That's what slope is, right? It's the change in the y value, which is price, versus the x value, which is square footage. So it's price per square foot. And remember, it's in thousands. So it's $0.109,000 per foot. So it's really talking about a $110 increase or $109 increase per square foot. Okay. The y-intercept of 98, now think that through. Why is there a y-intercept? Well, what if your house is not even there? What if you have 0 square footage? If you put a 0 in for x, you still get 98? Yeah. I agree, because the land, right? If you just buy land, well, in this neighborhood, it's going to be somewhere around $98,000 just to buy the land. Then you have to then build the house. So yeah, there should be a y-intercept in this equation, because even really small houses are still going to cost a decent amount because you do have to buy the land that it sits on. Okay, now there's 2 main questions. It says a 3,000 square foot house would be worth how much? Well, in that case, you are just plugging in 3,000 for x. So you're just taking 0.01098 times 3,000 plus 98, and you get like 427. So it's saying that a 3,000 square foot house would cost 427,000. You're using this equation, and you could even use the graph. You could hit trace, as long as you hit. See how you hit trace and you're on the plot. If you hit down, you're actually on the line now. So you could hit trace and you could put in 3,000 now. And then it will tell you that. So it's finding. You're using the line of best fit to model how this would work. Oh, let's let the house be 3,000. What would it cost? So let's let the house be 2,000. What should it cost? Let's let the house be only 1,000 square foot. What should it cost? So I'm on the line. Again, if you hit it right away, if you just hit trace, it's going to say plot. And you got to scroll down to make sure you're actually on the line. And then you can trace any value you want. Okay? The second question says, $150,000 house, how much square feet would it have? Well, now you're doing the opposite. Now, instead of plugging in 3,000 for x and finding out the cost, Now you know the cost. So you're plugging in 150 for y and solving for x. So you're just doing this on paper. You don't even have to use a graph. Now, if you wanted to use a graph, you could do what we've always done, and you could graph 150,000 and then graph it, and then you could find this intersection. Second, calc, intersect, and I could scroll down, and this intersection is going to be right there. It's saying that a house that costs 150,000 would have a square footage of 471. Remember, this would be a really small house, but it still costs 150,000. But remember, this neighborhood, well, the neighborhood model is that the 98,000 is just the land. So yeah, it is still going to cost a lot. Like if you live in San Francisco or Chicago, dude, you're paying a lot of money just to live where you live downtown. So you're not going to get a very big house for 150,000. And then I think the last question talks about the R squared value, which we discussed. The higher the R squared value is, the closer the R squared value is to 1, the better the fit, and the closer it is to 0, the less the fit. And again, here, I believe the R squared value, if we're back there, what we did, stat, we want to calculate a stat, we want to do a linear regression, and when we did that, it gave us that R squared value of 0.58. That's a moderately strong relationship between those two things. Okay? So once your diagnostics are on, you're good to go. You got to turn your stat plot on, so you can hit second stat plot. You can look at a graph. If you don't see it, it's because you have a messed up window. So I changed the window to let my X's, which are the square footage, go all the way up to a 4,000 square foot house. And then I changed my Y's, which are the price, and I changed the Y max to a 500. Remember, the Y's are in thousands, so I made it a 500,000 square, a $500,000 house. Then when I graph, I'm actually going to see the data. Then I want to get the line. Again, I hit stat, and I edit it to actually put in the data. And then I hit stat, and I want to run a calculation to actually find the line of best fit. If you can't store, don't worry. So if you can't figure out how to store this into Y1, just run the calculations and then just write this down. Y equals 0.11x plus 98, and then go in here and just type that in. I mean, it doesn't even matter if it's not even that much. Even if you just put 0.11, you know, your answers are going to be off by like almost nothing, okay? And then you have to answer some questions. Typically, I'm going to give you one question where I give you the X value, like, hey, how much does it cost if the house is this big? And the other question is, well, if the house costs this much, how big is it? One question, I'm telling you the X value, and you're asking for a Y. And the other one is I'm giving you a Y value, and you're finding the X value. Okay? The back example looks at advertising, how much money you spend on marketing, and then how much your sales will increase. And so you're just going to put in the data, and you're going to run the same thing. And again, that one's even going to be a better positive correlation. You're going to end up with a R squared of like 0.9, which means it's really strong. And then you're going to answer some questions. Okay? I'm sure there's other videos out there on YouTube or Khan Academy that kind of shows you how linear regression works, but these are the main steps. And make sure you study up this weekend because our test is on Monday.